Right, anyway, so I've been working on my FARNELL power supply for, God, a few days now. And you never believe what the problem was. Uh, yeah, I farted about swapping transistors out. And I must be getting senile. Well, I must be getting senile. I'm 60 like so. um, in the past, the first thing I would have checked was the output transistor. Now, oh, it's in here somewhere. Where has it gone? I've chucked it in the bin now. Oh, there it is. Right. Oh shit, there's crap all over it. Right, so the output transistor, which I was talking about the other day, I can't get the crap off it, is a tip 42A, right? Now, what's interesting is it's piggybacked, you see, with a driver transistor down there, and I was explaining this, and what was strange was that it was testing fine. The tip 42 is right underneath that big green looking resistor. Now the one that's replaced, I can't get the light on it. Hang on a minute, let me just get my pointy thing. The one I replaced is right down. Now I've got another light now. Trying to get it's in an awkward place actually. It's a bit dark down there. Actually, try that. Let's see. That should work. Anyway, the one I replaced is right there. I'll get the light on it right. Right. So that's the one I swapped out. And why did it fail? Well, it seems that what happened was the tab had been coming into contact with the chassis, so it was intermittently shorting out. You can't really tell from the back, but I do have a micro washer between the tab and the case, and I don't get it. I don't get it because this is connected to ground anyway, right? But there's two grounds on here. There's a floating 0-volt ground, and then there's because there's two rails, as I'll show you in the diagram. Even though the schematics for a later model, if I can grab it, the schematics for a later model, because we've got the main output bridge there, rectifier section there, then we've got this other section here for these two diodes. So there's two grounds, and the grounds should be tied together, and I'm a little bit baffled as to what happened, but it seems like the output, well, this is a NPN, but the actual transistor that's in mine is a PNP because it's an earlier version, right? It seems like what happened was the base emitter was intermittent. So every time I was poking it with my meter, it read all right. It seemed to, it checked out, but it's in series, you see. It's actually, it's a Darlington pair configuration, which means that the base of the driver transistor goes through that one and through there as well, through the output transistor. So when I was checking it on the diode test, it was taking a different path. The meter testing was actually going for the driver instead of the output transistor, but the output transistor was open. I didn't know. Yeah. Duh. So you can see from this diagram here, the base of this driver transistor goes to the same connection as what you would get if you were connecting to this. So if I was connecting between this pin and there, it was still finding a path through. Anyway, whatever. Whatever. The moment of truth. Let's turn this thing around. Turn it on. Yay! Look at the voltage. Look at the variable voltage control now. Watch this. It's working. It's fixed. I'll go to the second range, which is 10 to 20 volts. Adjust it. Now I just need to make sure my current limiting is going to work properly. That's working. Let's go to the 20 to 30 volt range. Adjust it. It's working. All fixed. Finally. Really strange goings on I've had with this power supply. I knew there was something wrong. There was something wrong with the rails because there was no voltage at this top end here on these resistors. As it turns out, the reason for that is that this top end of the circuit is getting its voltage from the actual output transistor, which was open circuit effectively. Anyway, the tip 42A is not standard for these old power supplies because I couldn't get the original transistor for it, and I'd originally stuck one of these in it. It worked fine. I found another tip 42A which I've stuck in. It's going back in the bin again. But it's working now, and checking all the temperatures of the Zener diode with my finger. Cold. I replaced these two little transistors with ZTX transistors actually. I've got two ZTX 651 and a ZTX 751, I think it is. Anyway, these are pretty well balanced, and these need to be, because these two transistors right here, I've got some crap on my finger now. These two transistors right there, look at the diagram, are actually these here on this diagram. So they're actually meant to be balanced, a balanced set. And these are PNPs on here. Mine are actually NPNs on my power supply. So yeah, and I tagged them because the tagging was wrong because it's for a later model. So they're actually VT3, VT4. So I've actually used two ZTXs for this circuit because it's they have to be matched and closely coupled. This is part of the current limiting circuit. So anyway, I've got to test current limiting. I've got to set that up now, which I haven't done yet. I have to put a load. I have to put a load across the output section. What can I run? I could run a motor. Let's go and grab a motor or something. Oh, I know what I could do. I can put some current through these NiCads. I suppose. Oh, actually, let me see. I've got a 250 volt bulb, but I've got to have a microwave there. No, actually, I'll get this motor. I'm just going to run this motor on and clip that onto the power supply, and then I can adjust the current limiting to see what. Right, so I need to clip on to here. So that's positive right there. So we'll just clip onto that diode actually. So that's positive, and that's right, positive. I'll turn the voltage down a bit. I don't want this thing to fly off the table. And this one's negative. So I want to test the current limiting is working. Okay, let's find a clip-on point. Oh, it's working. Oh, motor's gone in. It's going. Alright, that's just the current limiting, which is at the back of the unit, which is almost 3D printed. Let's turn this down. Oh yeah, cut out. Turn it up slowly. Let's just put a load. Let's go to current. Right, we're drawing. Oh, the current limit is not working right yet. Let's turn it the other way. The pot needs to be higher up. I want it to, right, turn it back a bit. It's working. The current limiting is working. I had to adjust it. Yeah, so that's current limiting. As I'm turning it down, that's the minimum current. Oh, it's gone right up now. It hasn't started either. That's strange. Oh, the motor was stalled. Not enough voltage. Anyway, current limiting is working great. So I'll set it to 500 milliamps. Turn the voltage up a bit. This motor's fucked. Yeah, we're in business. Turn the current down. Right, this is current on up and down. Yeah, it works. It's good. We've got it working again. This motor draws quite a bit of current when it's running. Yeah. Finally. Yeah. Let's see what, if I can punch the voltage up now. What voltage are you on now? 15 volts. Let's adjust the current on it. $20 volts. Probably going to burn the motor out. I'm going to set it about 100, about there on current. Midway point. See if anything's getting warm in the back. I can screw this board back in now. I'm happy. Yeah. Alright, it's working. Anyway, I'll unclip this now. Right, so all sorted. Finally, after what? I think this must be the longest repair I've ever had to do. Well, in a long time. I used to fix this blooming stuff in maybe 3 or 4 hours. But I'm getting old and senile, I suppose. Yeah. Great. New life. Anyway, that's the update on the FARNELL L30 power supply. I suppose if I turn my phone upside down, so this will be right way up, the bloody phone would flip the image around again. So I noticed on the preview thing on the YouTube, it was upside down, so I'm trying to get it right way up. But yeah, so there it is, working again. So I can't get it all. I've got to put the board, screw the board back in and put, yeah, tidy up the wiring a bit. And this resistor, which is sticking up, which I actually changed for a different resistor, I'm going to push that all the way down, solder it in place, because it seems to work fine. So it's probably more stable than it was before, actually, because I used to get some issues with stability. The resistor I took out of it is in the bottom of this can. It's that one there. It was reading low in resistance, supposed to be 680 ohms, but it was reading 520. So I stuck an 820 in there, which is right there, which I've got to push down flush with the board now. So it's working fine with that, so that's all that matters really. And even though I had my printouts, wires kept falling off here because I'm moving it around. The wires kept dropping off all the time, driving up the wall. I keep soldering back on again, so I've just got to tidy this lot up a little bit and finalise it. Put that little rubber thing, needs to be slid down like that onto the wire. Yeah. Anyway, so there we go. Finally, I can get back to my project, which is my generator project, which is over there. I can finally get back to doing that. You see, I needed the power supply. I've got a big bulky power supply in the cupboard, which is it can deliver us like 10-15 amps, but it's not currently regulated. This power supply is crucial for doing my experiments because it's got current limiting built in. Whereas my big power supply doesn't have current limiting. It has a trip if you overload it, but it doesn't actually limit current. So one thing I never fitted to it was current limiting. So that's why this was crucial to get this fixed, because without this I can't run all my tests without the risk of damaging stuff and blowing things up, you know. So now I've got this working again, I can set my current limit in, I'll be alright. Anyway, yeah, I'll probably see to that tip 42 that I put in there. I might need to put some thermal paste on it because I don't think I actually put some on there. I'll just loosen the nut and stick a bit of thermal paste underneath it and stick it back down again. And then that'll be done. Because as I was saying, I was doing testing, so there's no point in putting thermal paste on it while I was testing it because I might have had to yank it out again and then I get it all on my hands, you know. That's it. Thank you for watching. 15 minutes. Wow, time flies.